We will solve the following exercise. The exercise is a number 2.44. The rope ABC exerts forces FBA and FBC on the block at B. Their magnitudes are equal. FBA equals FBC. The magnitude of the total force exerted on the block at B by the rope is FBA plus FBC, and this is equal to 920 newtons. Determine FBA by expressing the forces FBA and FBC in terms of components. Alrighty, so as always, first I'm going to solve the exercise. Second, I'm going to explain what was needed for me to solve it. We will start by determining what the exercise is asking. Basically, it wants us to determine the magnitude of FBA. And it is giving us a hint. We have to do it by expressing the forces FBA. So FBA as the vector, which means in terms of components, and FBC as well, in terms of components. So let's start with FBC. So basically we have this force which is pointing towards this direction, and it has a 20 degrees angle with respect of the x-axis or the horizontal line, which means that I can determine FBC as a vector by using the cosine and the sine of those 20 degrees. So FBC multiplied by the cosine of 20 plus FBC multiplied by the by the sine of 20. And that's it. This is regarding the y-axis and this is regarding the j-axis. Now, in the case of FBA, we just have one component. It doesn't have any variations or any other angles. So we can first determine that this component is going to be negative, since it's pointing towards the opposite direction for y. And as I mentioned before, it's the only component. So FBA equals FBA negative along the j-axis. And that's it. Now, for us to solve the exercise easier, we have to use a statement that the exercise gave us, which is that FBA is equal to FBC, which means that FBA, the magnitude, is equal to FBC, the magnitude. Hence, I can call this unknown as F, because it's simpler. So I can get rid of this, and this. Alrighty. Yeah, that's it. Now we will use the second statement. FBA plus FBC equals 920 newtons. How can you determine a magnitude of a vector? By using the Pythagoras theorem. Remember the one that is square root square, and you just have to take into consideration the x component and the y component the square, and take the summatory between those two, and the square root of that is equal to the magnitude of the vector. Now, because of that, I'm going to write down in green that FBA plus FBC, the summatory of those two, is equal to f cosine of 20 along the I direction plus f times the sine 20 minus f along the j direction, right? Maybe it's easier if I put this within the parentheses for us to determine the components, the first and the second. Well, what I did right here basically is take this component and add it to these two components. I cannot do it, for example, right here, because x or the y-axis doesn't have anything to do with the j-axis. All right, I can only do it right here. So yeah, basically I place it right here. Now the magnitude, this is not the magnitude, this is the summatory. Now I'm going to determine the magnitude. The magnitude FBA plus FBC is going to be equal to f cosine of 20 square plus f sine of 20 minus f square, and the square root of that, and this is equal to 920 newtons, right? I'm going to get rid of this square root, so but if I do that, I have to place a square on the other side of the equation, right, for us to keep the equality. Alrighty, I'm going to start playing with this equation for me to solve f and basically determine the magnitude, what the exercise is asking. There is two possibilities. You can do it with the calculator using the solve button, or you can do it manually. I'm going to do it manually, and then I'm going to confirm that answer on the calculator. So basically this is equal to f squared times the cosine square of 20 plus, and this is a much larger equation, so please follow me. F square times sine square of 20 minus 2 times f sine 20 times f plus f square. Yep, that's it. And this is equal to 920 square. Now, these two are multiplicated, so I can get rid of this f, but I have to put a square right here. And now I can take out from every single part of the equation what it's being repetitive, which is f squared, and what's left is cosine of 20 plus sine square of 20 minus 2 sine 20 plus 1 is equal to 920 square, right? Now this is a trigonometric property. This is equal to 1, which means that f squared, in parentheses, 1 minus 2 sine 20 plus 1 equals 920 squared. But I can get rid of this one, and place a 2 right here. 1 plus 1 equals 2. And finally, I can say that f squared is equal to 920 squared divided by 2 minus 2 sine 20. And since I don't need the square but the base, I can place right here in a square root. Right, so the square root of 920 squared divided by 2 minus 2 sine of 20. Please make sure that you are using degrees. And this is equal to 801.9855 newtons, which is the final answer. Alrighty. Yeah. The exercise wanted us to determine FBA, the magnitude of FBA, and the magnitude of FBA is equal to F, which is this. So right here, guys, we have our final answer. Now we will double check that answer using the calculator, using our first equation, which was this one. So in the case of F, I'm going to change, okay, I can call it F. So F times the cosine of 20. Remember that if you don't have the same letter, you can change it to, for example, X, and basically your F is X on the calculator. It doesn't have any problems regarding that. And this is a squared plus F sine 20 minus F squared. Remember, I'm writing down this equation, equals 920 squared. Let me check if I wrote everything correctly. Yep, I think so. Yep. Now, shift solve. Okay, it is showing an error because I've used F. So I'm going to change it to X. Shift solve. Yes, I want to solve it for X. Remember, the number that I place right here is the one that the calculator will try in the case of F. First, what the calculator does, and I've mentioned this on the previous videos, is that it creates an iterative mode in which it is going to try every single number until this equation or this requirement is validated. So this equal is an equal. And the number that I place right here, for example, if I place 2, it's going to be the first number that the calculator tries. So it is going to start by 2. This works, for example, if I am using pretty difficult equation and I wanted and I want the calculator to solve the equation faster. So if I probably know that it's between, I don't know, 100 and 200, I can write down this number and the calculator is going to solve the equation a lot faster. In this case, this is a pretty simple exercise, so I can write down 2, 1000, a million, and it is going to do it very, very quickly. I hope I made myself understand. So for example, if I place a 2 and I write down equal, you see it is going to be pretty fast. And guys, as I mentioned, the solution is 801.9855 newtons. And that's it, guys. This is how you can solve this exercise.